Hello everyone. We are going to start with the chapter Chemical Reactions and Equations, which is the first chapter in Grade 10 CBSE Science. In this video, we will be learning about the importance of balancing an equation and to balance a chemical equation. So let us begin with our first topic related to balancing an equation. That is, why the need for balancing a chemical equation? Yes, the answer is law of conservation of mass. Like we humans follow certain laws, certain rules, like during driving or even when crossing roads or in school, how we wear school uniform, tie hair properly and so on. Just like that, atoms, molecules also follow certain laws which are called as laws of chemical combination. And one such law is law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction. This means that during a chemical reaction, we cannot create or destroy mass. Or in other words, mass of products in a chemical reaction must be equal to the mass of reactants. This means that before and after a chemical reaction, mass must remain same. So let us understand this with the help of an experiment. So here we have an image of calcium chloride reacting with sodium sulfate. So these are the reactants, calcium chloride solution and sodium sulfate solution. So initially, that is, the mass of the reactants was 300.23 grams. Once they were reacted, the products were calcium sulfate, which is a white precipitate, and sodium chloride. The mass of the products was 300.23 grams. So here, as you can see, the mass of the reactants and the mass of the products are equal. So this clearly indicates that mass of products in a chemical reaction is equal to the mass of the reactants. And to make the masses equal, the number of atoms that take part in the chemical reaction must be equal. And for number of atoms to be equal, we need to balance a chemical equation. And hence, balancing is very important. The next topic that we are going to study is balancing a chemical equation. Students, this topic we will be learning with the help of few steps. And to understand this topic, I have sorted out 3 different chemical equations with the help of which we will be learning balancing chemical equation. So let us go to our first chemical equation, that is H2 plus O2 gives H2O. Students, it is important to first recognize the reactants and products that are present in the chemical reaction. So here our reactants are H2 and O2. Very good. Reactants are the substances that take part in the chemical reaction. So here H2 and O2 are taking part in this reaction. Or in other words, we can say reactants are the substances that are present on the left side of the chemical equation. So here on the left side, we have H2 and O2. So H2O2 becomes our reactants. Very good. Products are the substances that are produced in a chemical reaction. Products are the substances that are formed during a chemical reaction. Or in other words, the substances that are present on the right side of the chemical equation are called as the products. So here on the right side, or the substances that are getting formed, the substance here which is getting formed is H2O, and hence H2O is our product. Brilliant. So now let us begin with our first step. So in our first step, we are going to start by drawing boxes around the molecules or atoms that are present in the chemical equation. The reason behind this is we are not going to write anything inside the box. We are not supposed to write anything inside the box. We will only be writing outside the boxes, and hence we are restricting by drawing a box. Brilliant. So this is our first step. We need to draw boxes around the molecules or atoms taking part in the chemical equation. The second step is to write down the number of atoms that are present for the reactants and products. So we are going to do that with the help of a table. So I have already drawn a table here in front of you. Let me quickly explain it. The first column says elements. So here what all elements are present in the chemical equation? Here only we have two elements involved, that is hydrogen and oxygen. So first column I have written the symbol of the elements present in the chemical equation, that is H and O. The second column says number of atoms of reactants. So we are going to write the number of atoms that are present for each reactant. So here for hydrogen the number of atom is, yes, it is written H2, hence the number of atom is 2. Similarly for oxygen O2, hence the number of atoms are 2. The third column is number of atoms of products. So here the product is H2O. Again separately for hydrogen and oxygen. For hydrogen, as you can see, it is H2. That means 2 atoms of hydrogen are present. And here we have only O. There is no number present for O. Whenever there is no number, we write it as 1. If there is no number, means only one atom is present for that particular element. So for oxygen, it is 1. Brilliant. So this is our second step. That is, we are going to write down the number of atoms of reactants and number of atoms of the products. The third step, we have to balance. We have to make the number of atoms of reactants and products equal. Now, to do that, it is convenient to start with the greatest number, the highest number. So here, as you can see, the highest number is 2. For hydrogen also it is 2. For oxygen also it is 2. But for hydrogen, students, the number of atoms in reactants and number of atoms in the products both are equal. Here also it is 2, here also 2. So that means that it is equal. So hence we are going to start by balancing the number of atoms of oxygen, because For reactants, the number of atoms for oxygen is 2, and for product, the number of atoms for oxygen is 1. So it is not balanced. Hence, we are going to start by balancing oxygen. So we have to make the number equal, and to make it equal, we are going to find the LCM of the two numbers. So here our two numbers are 2 and 1. So LCM of 2 and 1 is 2. Very good. So we are here already, it is 2. So no need to make any change. But for the product side it is 1. So we are going to multiply it by a number so that we will get answer as 2. Hence we are going to multiply 1 by 2. When we multiply, 2 multiplied by 1 is 2. So in the product side also it is 2, and in the reactant side also it is 2. Brilliant. So changes here we have made for the product side. So we are going to also make change in our chemical equation. So for oxygen we are going to write 2. But can we do any change inside the box? No. We will only make change outside the box. So outside the box we are going to write 2. Brilliant. Yes. But here as soon as we write 2 for the product, oxygen is not alone here in the product side. It is combined with hydrogen. So if we are writing 2 for oxygen, this means this 2 is also for hydrogen in the product side. So again, for product side, hydrogen, we are going to multiply it by 2. So now, once we made change here for hydrogen, here for the product side it became 4. But here for the reactant it is still 2. So again we are going to take the LCM of 2 and 2 2s are 4. So 4 and 2. So the LCM of 2 and 4 is 4. Brilliant. So again in the product side it is already 4. So no need to make any change. But in the reactant side it is only 2. So we are going to multiply this 2 by some number. So we will get the answer as 4. And to multiply, to get the answer as 4, we will multiply 2 by 2. 2 2s are 4. Excellent. So now we have made change for number of atoms of reactants for hydrogen. So hydrogen in the reactant side, we are going to write, we are going to make the change as 2. Very good. Okay. So this was our third step in which we balance the number of atoms. The fourth step is to check whether the atoms are actually balanced, if anything is left out. So let us check it once. For hydrogen, in the reactant it is 2 multiplied by 2, 4. In the product also 2 into 2, 4. So 4 equal. And for oxygen 2 equal. Brilliant. So we have balanced our reactants and products. So this was our fourth step, to verify, to check once again if we have balanced it properly. The fifth step is we are going to write the physical state of the reactants and the products. Students, by looking at a chemical equation, we should get complete information about the reactants and products, and hence we are going to also mention the physical state in which these reactants and products are present. So hydrogen, yes, it is in the form of gas, so we are going to represent gas with a small g. Like this, in bracket we will write it below the reactants and the products. For oxygen, the physical state, again oxygen is a gas, so again we are going to write G in a bracket, and this is the physical state for oxygen. H2O water, however, it is in the form of liquid. So we are going to represent liquid with small l. So this is the physical state for liquid. This is the physical state for water in the liquid state. So we have completed with the balancing of our first equation. Students, now we will be beginning with our second chemical equation. So here is the equation in front of you all. Fe plus H2O gives Fe3O4 plus H2, wherein the reactants are Fe and H2O and the products are Fe3O4 and H2. So I hope you all remember we were doing it step by step. So let us recall again all the steps and we will start balancing. Yes, the first step was to draw boxes around the reactants and the products. Very good. So we will be drawing boxes around the reactants, each reactant and each product involved in the chemical equation. The purpose behind drawing the box is that we are not going to write anything inside the box, but we will be only making changes outside the box. Brilliant. So this was our first step. The second step, yes, very good. We are going to write down the number of atoms for reactants and for products. Very good. So here we have the box, the table in front of you all. So first column element. So let us first begin by filling up this first column elements. So what are the elements involved in this chemical equation? We are going to write that one by one. Yes, the first element is iron, Fe. Brilliant. So it is Fe. The second in H2O, yes, H2O is a compound, but it is made up of two elements, that is hydrogen, very good, and oxygen, brilliant. Yes, so these three elements, let us verify for the product side also, Fe, O and H. Yes, we have written all these elements here. Let us now go to our second column, number of atoms of reactants. Yes, so for Fe, yes, no number is written. So I hope you all remember when no number is written, we write 1. Brilliant. For hydrogen, again in the reactant side, it is H2. So we write 2 for hydrogen. And for oxygen, it is no number again. So we write 1. Brilliant. Now let us proceed to the product side. Fe3. So for Fe in the product side, it is 3. Brilliant. O4. So it is 4. O. So here, yes. So we have to be very careful. So we are dealing with. So we are dealing with here oxygen. Yes. So we will write it for now oxygen. So when you are writing it, that time also we have to be very particular. We have to check. Good. So oxygen, it is 4. Very good. And for hydrogen, yes, as you can see, it is 2 for hydrogen. So this is our second step to write the number of atoms of reactants and products. Brilliant. Now let us proceed to our third step. In our third step, we are actually going to balance the number of atoms in the reactant and in the product side. I hope you all remember we are going to start by balancing with the highest number. Good. So here as you can see the highest, the greater number here is 4. So we will first start by balancing oxygen. Yes, so here it is 4 for the product side, 1 for the reactant side. So we are going to make them equal by taking LCM. Very good. So LCM of 1 and 4 is 4 again. So we are going to multiply this 1 by 4. Brilliant. So we are going to multiply 4 for the reactant side in oxygen. So we are not going to write anything inside the box but in front of H2. Very good. Now here oxygen was not alone, it was combined with hydrogen. So hydrogen in the reactant side, we also need to multiply it by 4. Brilliant. Now as soon as we multiply 4 here for Hydrogen in the reactant side, yes, the number changes here. So here also we are going to multiply by, very good, 4 again. So you all are good in maths also. Brilliant. So 4 for the product side in hydrogen. So hydrogen we are simply going to write 4 for the product side. Great. Now let us proceed for the last element, that is Fe here. Again 3, 1, it is not balanced. So we are going to multiply this 1 by 3. So we are going to multiply 3 in the reactant side. So we write 3. So this was our third step by balancing the reactants and products. Great. Now the fourth step is to actually verify if we have balanced it properly. Let us recheck it. For Fe it is 3, 3, brilliant. Hydrogen 4 into 2, 4 into 2, 8, 8, brilliant. For oxygen 4 into 1, 4, so 4, 4. So it is balanced. So our fourth step is also done. Now our fifth and final step is to write down the physical states. So let us start. Fe, yes, it is a metal. Metals are generally solid in state. Fe, iron is solid in state. So we represent solid with the help of small s. Very good. Here it is H2O. H2O here is actually in the form of steam in the gaseous state, because Fe, it is actually unreactive with water. So we need to heat water. We have to bring it in the gaseous state and then only it can be reacted with Fe. More about this you will be learning in the third chapter, metals and non-metals. Let us proceed to the product side. Fe3O4, yes, it is metallic oxide. Metallic oxide are generally solid in state. Very good. And H2 here, hydrogen is in the form of gaseous state. So we are done with balancing our second equation. Yay, thumbs up. So let us proceed to our third equation. This is the equation in front of you all. Al plus H2SO4 gives Al2SO4 thrice plus H2. Let us begin with the balancing equation. The first step, yes, very good. You need to draw boxes around each reactant and each product. Students, you may do this along with me here simultaneously. You can practice this, as you all already know all the steps of balancing the equations. Kindly ignore my lines. Great. So we are done with our first step. The second step is we are going to write the name of the element along with number of atoms of reactants and products. The first element, yes, very nice. It is aluminium. Next, let us proceed. It is hydrogen. Good. Before writing the next element, we'll quickly discuss some concept here. Students, H2SO4 is made up of two type of ions, two ions, that is H plus, very good, and SO4 2 minus. Similarly, Al2SO4 thrice is also made up of two types of ions. Yes, that is Al3 plus, very nice, and SO4 2 minus, that is the sulfate ions. Good. So now in this reaction, what is actually happening is SO4 ion from sulfuric acid is getting displaced to the product, to aluminium, and it is forming Al2SO4 thrice, that is aluminium sulfate. I repeat, SO4 ion here from the reactant side is getting displaced entirely to the product side, and hence Here we will not write separate sulfur, separate oxygen, but we will consider it to be one ion and we will write it in our table. So this is SO4 together. We are going to write the number of atoms here for SO4. Okay, let us proceed then. Number of atoms now for reactants, yes. Aluminium, yes. As you can see, no number, it is 1. Chalo, let us do this very quickly as you're already familiar with the concept. Okay, SO4 here now students. SO4 here, let me circle it for you all. SO4, now there is no number here for SO4 and hence for reactants SO4 is 1. But in the product side here, as you can see, there is a bracket for SO4. Yes, so this means that this 3, this indicates that SO4, there are 3 ions of SO4. So we write 3. Brilliant. Aluminium, hydrogen, 2 each. Good. So this was our second step, writing the elements and the number of atoms of reactants and products. Let us proceed to our third step. We are actually going to balance here the equation. We are going to make the number of atoms equal. For the product side, it is 3. Yes. How to start? We'll begin with the very good, the highest number. So highest number here is 3. So 3 here for SO4, but only 1. So we will be writing 3 here. Very good, the LCM basically. So SO4 in the reactant side will write 3. So we'll write here in front of H2SO4. Good, SO4 is balanced here. Yes, now, but as soon as we write 3 here, hydrogen in the reactant side also becomes 3. So we multiply here by 3. Same thing we'll do it in the product side. We'll multiply by 3. Brilliant. Now let us balance for aluminium. Yes, 2 in the product side. So let us make this 2 by multiplying 1 by 2. 2 in the reactant side will multiply it. Very good. So this completes our third step. Let us proceed to the fourth step. That is, we are going to recheck whether we have balanced it correctly. Yes, aluminium 2, hydrogen 6 and SO4 3. Perfect. We have balanced everything up. Fourth step is completed. Now the fifth step, that is writing the physical state. So aluminium is a metal, so it is solid. H2SO4 is acid. Acids are basically diluted acids. So it is aqueous solution with water, hence aqueous. So for aqueous we write AQ. Even Al2SO4 thrice, it is a salt and so we write it aqueous. And H2 is gas. Brilliant. So this is the balanced chemical equation for the third equation. Brilliant. Yes, so we completed all the 3 equations. So let us revise it. So these were the 5 steps that we did to balance a chemical equation. So you may take a screenshot of this or you may write it. All the 5 steps, you may pause this video and you may write it down. Okay, let us proceed. Now here there are few questions. Again, you may screenshot this or you may write it down. Pause the video and write. These questions are from the NCERT basically. So therefore, you may practice these equations. The more you practice, the more you will understand it. So practice makes the man perfect, it is said. So, you need to practice these equations. Here there are some more equations here. Yes, you may be able to do it. So kindly practice it and make this balancing of equations very, very strong so that you may be able to do the balancing part for the other chapters as well. So with this we end this topic. Thank you so much for watching.